Hi everyone, I'm Mr. Chia from AAA Teaching Center. Today I will start a topic called motion. So we need to learn how to define and calculate speed, average speed, velocity, and acceleration. And we need to learn how to sketch, interpret distance time graph and speed time graph. We also need to learn how to determine qualitatively from given data or the shape of distance time graph, speed time graph when an object is at rest, constant speed, accelerating, and decelerating. So what is speed? Speed is the distance traveled per unit time. It has a unit with meter per second, m/s or kilometer per hour. So speed actually in the simple terms is how fast you move. The higher the speed, the faster you move. So velocity is actually also speed, but velocity has direction. It's a speed but got direction. So actually it's the same thing, but speed doesn't have direction, it's just a value, and velocity it has direction. It is speed but have direction. So there's a formula for speed. Speed equals to distance traveled per time. V equals to S over T if you write it in symbols. Right? V is speed, S is not speed, it's distance traveled. T is time. So do not confuse with the S. Okay, let's see an example. A motorist completed a 2,500 meter race in 50 seconds. What was his speed? So we can do it together. So, okay, speed is equals to distance traveled per time. Recall that. Oh, by the way, if you want to do it yourself, you can stop this, pause this video and give it a try. If not, we continue. Speed equals to distance over time. Distance is 2,500 meter and time is 50 seconds. So the answer is 50 meter per second. So this is your answer. So what if the object is not moving at a constant speed? Means that Ali moved at very fast at first. Then he suddenly moved very slow. Then he moved fast again. Then he moved lagi fast. So we calculate the average speed for this case. Average speed equals to total distance traveled per total time taken. This is the formula for average speed. Let's see an example. If you want to try it out, you can pause this video. Okay, let's continue. Ali drive at a speed of 40 km per hour for 3 hours and he decided to speed up to 65 km per hour for the next 2 hours. What is his average speed? I will divide this question to two parts. So we need to find distance first because we are given speed and time only. We need to find the distance. So recall from the previous slide, speed is distance over time. So how do you move this? How do you find distance? You put distance as a subject. So speed the time you move it to the left hand side becomes multiply. Because we already divide, so you move it to left hand side become divide. So the formula for distance is speed times time. Distance equals to speed multiplied by time. Okay, remember this. Okay, let's continue. Okay, so for the first part, we need to find the distance first. Distance, okay, let's say distance 1 equals to speed times time, right? Speed times time. So what is the speed? 40 kilometer per hour. What is the time? 3 hours. So the answer is 220 kilometer. So same thing for distance 2. You apply the same formula. 65 kilometer per hour times 2 hours. You get 130. So total distance, you just add it up. 120 plus 130, you get 250 kilometer. So what is the total time? You get total distance already. So you got total distance already. What is the total time? You just plus 3 plus 2, 5 hours. So we got total distance, we got total time. Now we can calculate the average speed. Average speed equals to total distance 250 kilometer divided by total time 5 hours. So you do the calculation, you will get 50 kilometer per hour. So this is the answer. Okay, what is acceleration? Acceleration is the change in velocity per unit time. We have a unit for it, meter per second per second. This is how we pronounce. So actually, in simple terms, acceleration is just like how fast the velocity changes, like how fast the speed changes for an object. So we need to know that. There's a formula for acceleration. Acceleration equals to final speed minus initial speed over time. A equals to V minus U over T, and you write it in symbols. Okay, let's see an example. If you know how to do it, you can pause it and try it out yourself. If not, we can continue. Moto travels with an initial speed of 30 meters per second. He reaches his destination within 10 seconds and his final speed is 50 meters per second. What is his acceleration? So we use the previous formula. A equals to V minus U over T. What is V? Final speed? 50. U is initial speed? 30. Time is 10 seconds. So you do the calculation, you'll get 2 meters per second. This is your answer. So let's see, what is distance time graph? It shows how far an object traveled in a certain period of time. Let's say Ali moving at a distance of 5 meters in the first 2 seconds. Then he moved 10 meters, another 10 meters in the next 5 seconds. Then he moved 15 meters in the next 8 seconds. So what does we do to record this journey into a graph? Okay, let's see. So we need to know what this line represents, okay, in this subtopic. So if the graph is distance increasing linearly with time, like going up like this, it means that the object is moving at constant speed. Let's say 5 meters per second. What if the line is going down? It is also moving at constant speed, but just opposite direction. Let's say Ali is moving in right direction, 5 meters per second if going up. Then if it's going down, then it's moving in the opposite direction. Let's say left direction. Also 5 meters per second, but just the direction different. The value is still the same. Okay. So what if the line is horizontal like this? It means the object is at rest, not moving, zero speed. Okay. So for nonlinear, like the curvy graph like this. So nonlinear, if the curve is getting steeper and steeper, it means the object is moving increasing speed. Means the object is accelerating. If the curve is getting shallower and shallower, means the speed of object is decreasing, is decelerating, in other words. Okay, remember this. Alright, let's see speed time graph. It shows how an object speed changes over time. Let's say Ali, again, moving in 2 meters per second in the 2 seconds, in the first 2 seconds. Then in the next 3 seconds, then he moved 5 meters per second. Then in the next 5 seconds, he moved 10 meters per second. We need to record all this in a graph. That's what we do. So if the graph speed is increasing linearly with time, what does it mean? It means the object is accelerating. The speed is increasing. What if the line is horizontal? Means the object is moving at constant speed. Okay, what if the lines go down? It means the object is moving with decreasing speed, or we say decelerating. Okay, let's see nonlinear graph. If the curve is getting steeper and steeper, means the object's acceleration is increasing. Otherwise, if the curve is shallower and shallower, means the acceleration of the object is decreasing. So you need to remember all this. So let's recap what we learned today. We learned about speed, velocity, and acceleration, and their definition and units, and their formulas, distance time graph and speed time graph, what the lines represent. Okay, so next we will learn how to calculate speed, distance travel, acceleration from the previous graph just now, the two graphs just now. Stay tuned for the next lesson.